All right, and once again, these are your formulas that you have to work with. Right now we're going from polar. Look, it's easy. Just x, and so it equals -3, which is the equation for a vertical line going through -3. Done. One thing about this, look at this. This equation looks very similar to this equation. I have different numbers, different sign, but if you put the trig function over here, you get one thing, versus when you put it over here, you get another thing. So just be careful because it looks so similar. The rectangular equations look totally different though. Here, that's a vertical line. This is going to be a circle. So anyway, here, let's draw this. Which way do I draw the circle? Above, below, or left or right of the pole? Above, because it's positive sign. And by the way, the radius is 4. Look, the 8 means the farthest you go above the pole is 8. The center is halfway. So this is our circle. Like I said, it's above the pole. Radius of 4. Center of 0, 4. All right? Now, we need to get this to be rectangular form. That's our goal. Here's the deal. You have these equations, and when you get r squared, you're going to replace r squared with this. I guess my point is that's going to happen in a couple of different ways. Really, your focus in this problem needs to be that you have sine, you don't have r times sine, and you need that. So in other words, I'm going to multiply both sides of the equation by r, because the right side becomes 8 times r sine of theta, and r sine of theta is the same as y. And it turns out I get r squared on this side, and r squared gets replaced with x squared plus y squared. Okay? Now listen, if you just do that much, you certainly get partial credit, because it's rectangular form. It is all x's and y's. No r, no theta. So that's like a partial answer. But that's not how we write equations for circles. So we're going to do some algebra here. Bring the 8y over, becomes plus y squared, then minus 8y. Leave a space there because you need it. And we're going to complete the square. Okay? Before I do that, let me kind of remind you what the idea is. Let me just make something up. If I gave you this, actually not that, this, then what you get if you multiply it out is x squared minus 10x plus 25. Okay? Another example, if I give you x minus, or we'll make it plus 7 squared. That equals what? X squared, then what? Plus 14x, good, plus one more. What if I gave you x minus 11 squared? What do you get? Now let me turn it around. What if I gave you x squared plus 20x plus something? The goal is when you complete the square polynomial and make it into a binomial squared, okay? What would go here? It'd be x plus what? 10, because notice this is always half of that, right? So that's going to be a 10. But these do not equal yet. What's missing? And putting the 100 there is what completes the square, all right? So I go back to the problem we're working on, and we want to take this and make it into a trinomial that equals a binomial squared. It'll be y minus what squared? 4. But what's missing? 16. Now, we need to have 16 there, but you can't just add a 16 to one side. You have to be balanced. So don't forget, in your equation, you add to both sides. But for the purpose of making this into a square trinomial, that can be written like this. So we've completed the square, and we're done, basically. Bring the x squared down. This right side is 16. And that is the standard form equation circle. Notice one big detail. The center was at 4, wasn't it? Positive 4, 0, 4. But you see y minus 4 in the equation. Don't forget that happens. The sign is opposite in the equation. And this is not r, that's r squared. So the radius is, so I'm sorry? The center is 0, 4, and the radius is 4, which is what we drew, isn't it? Okay. Next. This is a little different. All we have is theta. So which of my equations, when I'm trying to go from polar, which ones involve just theta? Only a tangent of theta, right? Because these I can't use because I don't know r. So we're going to use that one. Write that down. Tangent of theta equals y over x. And this one kind of feels weird, frankly. So here's my formula, equation I'm going to use. All I know is theta, so plug in theta. I don't know y or x, so they just stay there. But what is tangent of pi 4? 1. And you multiply both sides by x, you get y equals x. And there you go. Which, by the way, if we graph the original, this, theta equals pi over 4, we rotate to pi over 4, and plot every point you can think of with whatever radius you want. It's radius 1, 2, 3, 4, you get all these points. The radius that's negative, you get these points over here. So you get a whole line of points when you plot this equation, which is what this is, right? So, this one, what is it? What shape? Circle centered at the origin or at the pole with the radius of 5, right? Not sure. Yes? I know what sure means. Not thinking. Now, look, we're trying to get rectangular. Here you want to square both sides. Square r and square 5, you get this. Here you wouldn't want to multiply both sides by r, that nets everything up. So I'm saying you have to choose. Sometimes multiply both sides by r, sometimes square both sides. What is r squared? And you're done. X squared plus y squared equals 25 is the equation for a circle centered at the origin with a radius of 5. That one's easy. All right, now we're going the other way. We're going from rectangular. What does x get replaced with? R. Someone say it out loud. R cosine theta. Y gets replaced with r sine theta. And then equals 8. Listen to me. As soon as you've done the replacement, you have gotten a polar form, but I want to see it with r by itself. Okay? So this gives you partial credit, which you knew how to substitute. Look, I want to get, this is one big term. Things multiplied onto r. So to get r by itself, I'll divide by 4. Here, I'm going to leave the r squared on this side. Everything else is going to be divided away. When I divide by 4, I'm left with a 2. And it gets divided by the cosine and the sine. Because it's r here times r here. Like I said, you have really what, 1, 2, 3, 4, 5, 6 different factors, 5 different factors in that. 4, r, cosine, and sine. The 2 r's are left over here, and I divide away the 4, the cosine, and the sine. And so I get this, which frankly, I'll take that as an answer. I said I want to see r by itself, but like in Linda's case, we write as r squared equals something. So that's acceptable. If you want to type in the calculator, though, you'd have to type it in as plus or minus square root of that. So you can write it like that. That's acceptable. If you do, make sure you put the plus minus. And for that matter, up here, you could write this another way. Dividing by cosine, same as multiplying by secant. And then dividing by sine, same as multiplying by cosecant. There's another form of the equation. And I show all of them because I'll take any one of those. But the book might show one and not the other, and you need to know that they're equivalent, okay? Now, let's talk about the graph. Anyone know what that is? You graph that thing? If I solve for y, I would divide by 4x. Well, 8 divided by 4 is 2, so you get 2 over x. Let's break that down. Let's see. The rectangular equation written as a function. And I'll just tell you that is a parabola. I mean, not parabola, hyperbola. Just draw it, sketch it. One branch is in the first quadrant, the other branch is in the third quadrant. In this one, frankly, I'm not going to expect you necessarily to memorize that, but know that's a hyperbola. Okay, that's. We'll do hyperbolas later in the semester, and you've done them before, I presume, in Algebra 2. But if you type, my main point is, you can check these with the calculator. Go to y equals and type that in. You see this? Go to y equals in polar mode and type this in, and you should see the same shape. Although you might have to do the plus to get one branch and the minus to do the other branch. I'm not sure. Sometimes you get the whole shape with just one of them, sometimes not. All right, this one. What would you get if you graph that? What shape? Look. What would you get if you graph that? Parabola that opens up, yes? So this is a sideways parabola, which opens which way do you think? Left or right? Right, because this one opens in a positive direction, but vertical. This one opens in a positive direction, but horizontal. By the way, watch this. If you weren't sure, make a table. The thing is, in this example, x is a function of y. So you'd want to pick y values. And if you plug them in, if you square that, you get 0. If you square these, either way you get 1. If you square those y values, you get 4. And so now if you plot those points, you'll have a good idea what the graph looks like. Once again, hit the origin. When y is 1 or negative 1, I hit an x value of 1. And when y is 2 or negative 2, I get an x value of 4. So I'm saying you realize that it opens to the right by just making a little table. You should realize it's a parabola. Now, listen, you have y squared, but it's not x squared plus y squared, so we're not using that formula. I'm just going to replace x with r cosine theta and y with r sine theta. But of course, that's all squared. Okay? And then this is just really r squared sine squared. Distribute the exponent. Now, listen. My equation, well, you tell me, how many terms are in my equation? So far, this has been a complete failure. No one says the correct answer to the term. To the answer to the question, I mean. The answer is 2. This equation has 2 terms. Look at this. If I read this equation, I'll say it has 3 terms. They don't count 0. If I take the same equation and move the 6 over, it looks like this. Either way, I'd say it has 3 terms, okay? So when I say a term, it's a part of the equation that's separated by pluses or minuses or maybe an equal sign. That's a term. And watch this. If I took and wrote a term like this, I said, oh, it's 3x squared y cubed z. That is a single term. If I do that plus 7, I have 2 terms. So everything multiplied together forms a single term. Okay? This thing has 2 terms, and they both have a factor of r, don't they? By the way, if I had a third term like that, that would mess everything up. It would be a much harder problem. Now, we're going to divide away a factor of r. Before we do that, I need to mention a little caveat here. The point is, watch. This is not always true. When does this fail? When you plug in 0, right? And so if you're solving equations, you generally shouldn't divide by the variable because you're losing 0. The thing is, though, what would I get if I graphed the equation r equals 0? Just a point? The pole? Right? I don't care. I mean, it doesn't really affect my graph in this case. I don't care about it, so just be very careful, I'm saying, about dividing by a variable. So you lose one of the here, it goes away entirely from there. How do you get r by itself now? Divide by sine squared. So I'm going to put the r equals on the left, though, just because we like it that way. Put the sine squared under the cosine. And I have the polar equation for that parabola. You type that in the calculator, you'll see that parabola. There are a couple ways we could write this equation, though. Other ways. What you could do is split this fraction up, because I don't have a name for that particular ratio, right? I could split it up like this. I could just put cosine one place and sine squared in the other fraction, in which case I could write that as cosine times what? What do you call this? Not secant squared, but cosecant squared. And the nice thing is now it doesn't have any fractions. I could also do this. I could split the fractions up into 2 fractions again, but I'm going to split the sine up into 2 sine. I'll put sine in each denominator. And I'll split cosine in one in the other, because I don't have 1 factor of cosine. And then this is cosecant, just plain cosecant. It's cotangent. Listen, I'll take any one of these answers. I don't care. Let's get r by itself, and I'm good. Just wanted to show you it can be written various ways. Once again, this one has the advantage of just having sine and cosine in it, which you can easily tap in the calculator. but it might be written this way. That way it doesn't have a fraction. Okay? And then this one. The last one, right? All right. Listen. What people messing up on over and over again all day long is thinking that the center is at 2, 0, and it's not. It's a negative 2, 0. So let's do the algebra. It's actually not that bad. If you FOIL this out, you get x squared plus 4, and then plus y squared. And then bring down the equals 4. Okay? We're just simplifying. The 4's go away, don't they? I mean, you could show the minus 4, but I'm just going to scratch it out. Let me rearrange this. We have x squared plus y squared. I'm going to put those next to each other. Plus 4x equals 0. This is just r squared plus 4 times r cosine theta. Once again, if it had a constant, it would be a much uglier problem, but it doesn't. So just divide by r. I mean, you can do it later, I'll just do it now. You divide everything by r, and you get r plus 4 cosine theta equals 0, or r equals negative 4 cosine theta. Like the algebra is not too bad. And by doing the algebra, you get the sign right. What do we see if we graph this? A circle to the left of the pole, right? And just a reminder, when you graph these circles, that 4 is not the radius, the 4 is the diameter. Base that 4 being there means the farthest point from the pole would be 4. And so that point's there. The center is here. But I got to fix that. That's just very poorly placed. There. And I'm just going to sketch these. This will be 2 above and 2 below because the radius is 2. And so there's our circle. And I want to go back real quick and say again, when you look at this normal standard form equation from Algebra 2, you're supposed to realize the center is not at 2, 0, but negative 2, 0. And also remember that is not r, that's r squared. So if r squared is 4, r is 2, right? So just be careful. They're not terribly hard, but it's easy to make little mistakes.